on finding these complex or imaginary roots. So we're going to start with the quadratic equation y equals x squared minus 4x plus 5. Now, we have a couple methods of solving quadratic equations. One of them is by factoring, but not all quadratic equations are factorable. This particular one is not factorable. And then we have the quadratic formula. So, we're going to be using the quadratic formula, and just to review that, I know some of you are perfectly comfortable with it, but others are not. So that quadratic formula is x equals negative b. Make sure that negative is very, very clear in your notes. Plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. If I pull this graph up on Desmos and I zoom in on it, obviously there are no real roots on this one. This isn't crossing the x-axis anywhere, so there are no real roots. What I'm going to end up with when I put all this into the quadratic formula is a negative under the square root sign. So that's what we're going to deal with when we get there. So I'm going to plug everything in. Remember, the number before the x squared is your a value. The number including the negative before the x is your b, and the number by itself is your c. So we're going to plug everything in there. So negative 4, and I would encourage you guys to plug everything in exactly as it is first without reducing anything in your head, so you make sure you get all the negatives taken care of. Put any negatives in parentheses so that you remember that a negative squared is always a positive. All divided by 2 times 1. So then I'm going to start simplifying. I've got x equals a double negative 4 is going to give me a positive 4, plus or minus the square root. If I were to try to put this in the calculator as the square root and I just plugged all that stuff in, I can do that if I have real roots, but I'm going to get a non-real answer and an error message on this, so I'm going to just show my steps on this. Negative 4 squared is a positive 16. If you're going through step by step, this number will always be positive. And then minus 4 times 1 times 5, so that is minus 20, all divided by 2. So that's 4 plus or minus the square root of negative 4 divided by 2. And that is where I have to take into account what we learned last class when I'm dealing with the square root of a negative number. So in the last class, we determined that the square root of negative 1 equals our imaginary number I. So if I have the square root of negative 4, and some of you guys are already there, so don't worry about it, I can split that. I need to make that more obvious. I can split that so that it is the square root of 4 times the square root of negative 1. And the reason I want to do that is because the square root of 4 does have a square root. And what is that? 2. And then how do I write the square root of negative 1? I. So this is 2i. So what I'm left with here, and this should be x equals, is x equals 4 plus or minus 2i divided by 2. They can't always be reduced, but this particular one can, because what is 4 divided by 2? 2. And what is 2i divided by 2? I. So that is my answer. That's my complex, not complex, that's my imaginary roots. And I should say, those are my imaginary roots because it's both the plus and the minus. So if I'm going to write this in factored form, this is going to be, scooch that up. It's always going to be the x minus, and I'm going to have to use brackets because I also have to use parentheses. So x minus 2 plus I times x minus 2 minus I. And I can leave it like that if I want to, but some people don't like the double parentheses and brackets and that kind of thing. So I can also write this as x minus 2 minus I times x minus 2 plus I. And that would be y equals that. So that is my factored form when I have imaginary roots. So, other ones, hang on just a sec. So we'll do 2 of those examples. I'm going to give you the problem, give you some time to work on it, and then we'll go over it. So, the first of those that we're going to work with is x to the third minus 2x squared minus 3x plus 10. This should be y equals. So, if I'm not given a root, what I'm going to do is put that into Desmos or into the calculator to find. If I bring that up on Desmos, you can see that this is a third-degree polynomial because of those direction changes. And you can see it's only got one real root. And that one occurs at -2. So what do I know about one of my factors? X plus 2. Ben, sit up. So I have a factor at x plus 2. Now, for those of you who don't remember, I'm going to give you that first step into it, and then I'm going to give you some time to take it from there. Because it's been a few days since we've done this. So this is a third-degree polynomial. I'm going to factor this down to a binomial times a trinomial. That's why we have the 2 by 3 box. That first factor I'm going to put on this side, the x plus 2. Anybody remember what I put in that box? Whoa. Sorry, we had a weird lighting thing. X cubed goes in that first box. So remember, when you're doing this process, you're going back and forth between factoring something out and then figuring out what terms you need to have to get to the missing boxes. And then multiplying again, and then factoring again, until you get to the end of it. So, I'm going to pause the video, give you guys some time to work, and then we'll go over it. Okay, so, because I know this is x to the third, and I know this is x, this term right here has to be what? X squared, because x squared times x gives me x to the third. Then I also know, because I know this is 2 and this is x squared, what is this? 2x squared. So, the next thing that I know is that these two terms have to add up to give me a negative 2x squared. So what does that have to be? Negative 4x squared. And now I factor out, what does this need to be? Negative 4x. Then I take those two and multiply them to get negative 8x. And then I need my x term to be negative 3, so what do I have to add to negative 8x? 5x. Which means I now factor out that 5, and then you always want to double check that your last two are multiplying together to give you your last term. So, now I have a partially factored form of x plus 2 times x squared minus 4x plus 5. And then I'm going to part, which happens to not be factorable. If we wanted to fully factor, we could try factoring, but that's not going to work. We're going to use the quadratic formula on that. Now, we're not actually going to do that because we just did that on that particular problem. And that was unintentional, but that's how it came out. So this was the example that we just did, happened to be the remaining one here. So then my fully factored form, based on what I had on the other side, is going to be x plus 2 times x minus 2 minus 1 times x minus 2 plus 1. So x minus 2, sorry, all sideways. Not 1, sorry, I. X minus 2 minus I times x minus 2 plus I.